All right, section 1, 2. We're really moving now, aren't we? All right, I could say a lot of things, but I'm not going to. Whoops, got to put the microphone on. All right, here we go. Yeah, sure. All right, let's do some definitions first. This is kind of weak stuff. Definitely not really what we think of when we think of Algebra 2, but it's stuff we got to get out of the way because we got to set up some definitions so when we talk and we use words, we know what we're talking about. So here are some terms that they're going to use throughout the book, and we got to be on the same page. We got to know what these terms mean. All right, so when you're talking about addition, like 3 plus 2 equals 5, okay? These two things right here, they call the addend, A-D-D. We hardly ever use this word for these two, but this one we absolutely use a lot. What do we call the answer to an addition problem? The sum. So that's really important, okay? We will use sum quite a bit. Once in a while, they'll throw the word addend in there, okay, addend. Those are the two things that are being added together. But the answer to the addition problem, really for all of these, the answer to addition, subtraction, multiplication, division, those are the words we really, really want to learn. But they throw these other ones in there too, so we might as well learn those as well. Some of them I'd have to look them up because I probably wouldn't even remember because I hardly ever use these words. I definitely know the answers to all of these things. But, so what if you had 3 minus 2? So, I don't even know how to pronounce that. I'm going to guess. Minuend. All right. Some teachers really make a big deal about this. To me, it's not that big of a deal because we hardly ever say these words. Subtrahend. Write them down, yes. If I'm writing it, you're writing it. Shouldn't even be a question. Yeah. M-I-N-U-E-N-D. Right? Subtra. S-U-B-T-R-A-H-E-N-D. Subtrahend. Now, here's the one that I really want you to know. 3 minus 2 is what? 1? So, what do we call the answer to a subtraction problem? The difference. Now, this is definitely a word that you should know. All right? That's the one that I think is really important. Okay, sum is really important. Difference is really important. The answer to these things, I think, are really important. All right, but I throw these other ones out there just in case you see them, just in case they pop up in a question. They talk about the minuend and the subtrahend. Shh, I'm in the middle of talking. So whether it's minuend or subtrahend, you never know when it's going to show up. So it's nice that we know what the answer is. What? I'm already done writing. It's in your book. Just look in your book. You got to keep up. I'm not writing that fast. All right, so let's do multiplication. Now the two things that are being multiplied, let's use that 3 and the 2 again. So 3 times 2, we'll put them both in parentheses. Both of these things that are being multiplied have one name. And I do think this is important, especially in Algebra 2, because we're going to be doing a lot of this stuff in Algebra 2. And these are called the factors. The two things that are being multiplied together are called the factors. That is important, okay? Like subtrahend and all that kind of stuff, minuend and addend. We hardly ever hear that. Factors you hear a lot. My handwriting's terrible on that. It's F-A-C-T-O-R-S, factors. What's the answer to a multiplication product? Did I say it? I don't even remember saying it. I'll have to rewind. All right, product is the answer to a multiplication problem. That's important too. All right, division, let's do division. Can't wait till we do some real math, can you? 12 divided by 3, okay? Or you could write 12, this symbol. I showed my other class this earlier today, so might as well show you guys. I don't know if I showed you this last year or not. Do you know where that symbol comes from? Do you know why that's the symbol for division?
No, what's the one that's like diagonal?
Yeah, you could do it diagonal. It's like this, but diagonal. But why is this? Why is this a symbol for division? Looks like a fraction, exactly. So look, the top, see the dot on the top? That could be like the 12. And the dot on the bottom, it's kind of like the 3, and it's a division. So this is really showing this, isn't it? All right, so that's where that symbol comes from. I don't think I learned that till I was in college. I think a college professor said that one time. I'm like, never even thought about it. All right, and now I see it and I teach it now. So 12 divided by 3. So again, the first two, they have special names. We don't use it too often, but they call this the dividend. Dividend, and this is the divisor. So the thing you're dividing by is the divisor. Now the answer equals what? 4. The answer, right, that's the one that I think is the most important, and that's the quotient. So use that word a lot. So the answers to these things are the ones that they're going to use a lot. One more. Exponentiation. Exponentiation, is that how you say that? Exponentiation. Yep, that's how you say that. Not a word that I use very often, but you're talking about exponents, right? So, like if I had like 3 to the second, all right? This is important. We're going to use this a lot. We're going to do a lot of exponent stuff later on in the book, okay? It's a huge Algebra 2 topic. We're going to do a lot of this kind of stuff. So we will use these words. So this is the base. That's super important. And obviously the 2, what do you think that is? The exponent. Okay? So the big number on the bottom is the base, and then the little number on top is called the exponent. It equals 9, but I don't know if there's really like a special word for that. It's just the answer, okay? The answer to an exponent problem. So I'm not even going to label that. I didn't put it anywhere on there. Let's do one more. I said that was one more, but I lied. I'll put that there. Let's do absolute value. Remember absolute value? You hate it? Yeah, it's the bars. So absolute value looks like this. You got the 2 bars, you got X in between. So what does that mean, absolute value? Now, you probably know how to do it. Like if I said, what is the absolute value of 3? It's just plain old 3, positive 3. What's the absolute value of negative 3? It's positive 3. So it looks like it doesn't change it, but it does. It changes this, doesn't it? Okay. Does it mean a lot of students incorrectly thinks that it changes the sign? Does it necessarily change the sign? In this case it does, but not in this case. What does absolute value always do? It always makes it what? Positive. Okay, always makes it positive. So if you're going to do an absolute value problem, if I had something like this, don't just take them individually. Do the stuff inside the absolute value first. Then you can look at it once you get that answer and then figure out, is it negative, is it positive? All right. So is it 1? Right. So watch. Negative 3 minus 2, add the opposite. That's the absolute value of negative 5. What's the absolute value of negative 5? 5. And that's how you do something like that. That's not really what we're trying to teach. Just want you to see that. Now, you could also think of it like this. It's not like an official definition, but it's pretty close to the definition of absolute value. It's the distance from 0. Very good. So you did learn that. That's good. So what if I put a 3 right here and a negative 3 right there? Remember we said the absolute value of positive 3 is 3. What this means is it's the distance. It's how far. If I measure something, we talked about this in geometry, I believe, last year. If I measure something, I don't look at something and say, oh, that looks about negative 3 feet. Would you ever say that? No, it's just 3 feet. It doesn't matter which direction you measured, right? I can measure from here to here or measure from here to here. And if it says 3 feet on my yardstick or meter or my whatever, what do you call it? A ruler, okay, tape measure. Yeah, that's what I was trying to think of. You don't say negative or positive. You just say it's what? It's 3 feet. Doesn't matter which direction. You follow me? So absolute value means how far away that this number is from 0. So let's count. How far? 1, 2, 3. It doesn't matter which direction we go. All right, it's just 3. 3 what? 3 centimeters, 3 millimeters, 3 inches, 3 meters, 3 feet, whatever. All right, and it's the same distance from here, isn't it? To 0. So from there to 0 is 3. From here to 0 is what? 3. All right, it's just the length. All right, we don't put negatives when we talk about length. Now, I've probably in Algebra 2, again, I've not taught out of this particular book. I used to teach Algebra 2 for a bunch of years, but it's been a long time since I've done Algebra 2. But I'm almost positive that they're going to do a lot more stuff with absolute value and that kind of stuff. So we'll learn way more about absolute value than just that. Oh my word, I almost hate to do this, but I've been doing this. I took my my CP geometry classes this year. I decided to start them off with an algebra review for a couple weeks before we jump into the geometry, because the last couple years their algebra skills were really, really lacking. So I made sure that we took some time and we just tried to help them out with the algebra, the basic algebra. So this is what I did just the other day, yesterday, day before, something like that. We're going to learn some rules for addition. All right, and hopefully you got these down pat. If you're in Honors Algebra 2, you should have these down pat. It shouldn't be a problem, but this is a good review. Just came off the summer. You might have forgotten a few things, so let's do that. So if you're going to add two numbers together, the rules for addition of two numbers, okay, we're talking two numbers. You have a couple scenarios. You've got addition when you have the same sign, and you have addition when you have what? Different signs. Don't all answer at once. All right, so let's do a couple examples. So the same sign is you add the numbers together and you keep the sign. All right, so that's the basic rule. We'll do a couple examples. Different signs, what do you think? Do you add the two numbers? If I'm adding a positive and a negative, what do? I actually subtract the two numbers from each other. Even though it's an addition problem, I subtract the numbers and I don't just keep the sign. I can't say that because they're different signs. Which sign do I keep? It's always the subtraction one. Keep the sign of the what? Right, the larger number. I'll just put a little that. Okay? So that's the rule. Remember that? Let's do a couple examples. We'll start off super easy. 3 plus 2 is 5. Very good. And we did this already. Negative 3 plus negative 2. Hopefully you were kidding on that. Negative 3 plus negative 2 is what? It's negative 5. Why? Does it follow the rule? Yeah, because they're the same signs, right? Same signs, negative and negative. I'm adding them up. I just add them. 3 and 2 is 5, and I keep the sign. All right, easy. What about subtraction? What if I did, let's do a different number. Let's go 7 and 3. What if I go 7 minus 3?
4.
Wait a minute. I didn't want that. Plus, there. That's what I want. Because I got to talk about subtraction. Because these are all rules for addition. All right. So I'm going to do another rule for subtraction. All right. So I want a plus here. That's what I was thinking. Okay. So 7 plus negative 3. Okay. They're different signs. So what do? I subtract the two numbers. 7 minus 3 is 4. But I keep the sign of the larger number. 7 and 3. Which one's the bigger number? 7 is positive. So what's my answer going to be? Positive. Positive 4. Okay. What about negative 7 plus 3? Yeah, you should be able to do this in your head, really, okay? And if you can't, you better learn, or you may want to find another math class to take. I don't know. All right, so negative 7 plus 3. What's the rule? It's addition. I got two different signs, so what does the rule say? Subtract the two numbers. What's 7 minus 3? Take the sign of the larger number. 7 is bigger. Now, some people that are kind of quick, all right, and thinking ahead a little bit and say, Mr. Hamrick, this is a -7. That's not bigger than 3. I'm talking about the numbers without the signs, okay? So just look at 7 and 3. What's bigger, 7 or 3? 7 is. 7 is what? Where'd my... Uh-oh. Uh-oh. What happened? I can't find my... Oh. You kidding me? What happened? What did I just do? This is not writing. See, that's the mouse pad on the computer, and this is the tablet, and it's not writing. Well, you don't think this is going to stop me, do you? It is unfortunate. Undo pencil. Zoom out. High ruler chagrin. No, let's not do that. Let's do that. Let's do that. All right, well, I am going to stop this recording, then I'm going to put another one, and then unfortunately I'm going to have to put them all together. So I'm going to stop this recording and then start again.